Welcome to Aviation Element Simulation Academy by Apurva. So today we will see how to perform front impact analysis on 1D mesh model. So the assumption which I have taken is the roll cage material is isotropic. All the roll cage members have uniform cross section. Roll cage is stationary, that is we are considering the situation when my roll cage is stationary and someone impacted on me. The time of impact is also an assumption. The speed of the ATV impacting on my roll cage is also an assumption. Force location where the impact will happen and constraint location, that is the suspension mounting points, are all we considered as the assumption. And you can see the animation of the deformation because of the front impact analysis. Then on side impact analysis we will have almost similar kinds of assumptions where we consider that some other car is impacting on the side members, and we will see the deformation and stress behavior on the roll cage where we consider the material is isotropic. Then time of impact, speed of ATV, forces location, constraints location, everything. We are assuming that these types of reaction will come. Then we will see on the rear impact analysis that my roll cage is stationary and somebody impacted me from the behind, that the forces, time of impact, speed of the ATV impacting on my roll cage, force location and constraint location, and you can see the deformation coming because of the rear impact. Then torsional analysis, we will see the case where my front torsional analysis, one front portion of my ATV or the roll cage is under torsion because one of the wheel is under bump and the another one is facing on the road. So rear portion I have constrained and I have applied a front torsional forces. So you can have a right torsion or left, or you can say clockwise, anti-clockwise. Similarly in the rear also you can have clockwise and anti-clockwise. Then bump analysis. So I have considered the front bump analysis. In the similar fashion you can do a rear bump analysis where all the wheels are facing the bump. Then rollover analysis, this is the condition I am considering when the front rollover happened, and then how because of the forces, what are the deformations and stresses generated on the roll cage. So generally we see the deformation pattern in these types of analysis, like how much my members are deforming because of the impact or because of the forces coming on the roll cage. Then we will also see a normal motor analysis there where we will see how the mode shapes are generated and what are the mode shapes generated and what is the maximum deformation on that particular mode on some frequency range. That frequency range we will see because of the road excitation, because of the engine vibration, and because of the speed of the ATV. So there are different reasons of the frequency range so that we can calculate. So we will start with defining or the procedure which you can follow to perform the static structural analysis using ANSYS Workbench 17.0. So the first thing is we have to select a static structural load case in the ANSYS Workbench 17.0. Then we define the engineering data, where the engineering data consists means we define the material in which we specify the different material properties like E, nu, rho. Then we move to importing the geometry. So we can import different file formats in ANSYS Workbench 17.0. So we edit some data like this is the 1D geometry. So we import a line data. So we add some options like check the box in front of line data so my software can understand this. I have a IGS file format which have a line data. Then we move to our next part, that is we define the part models and part behavior, like defining the cross section on the geometry, then defining the cross sections, what are the cross sections and what are the different connections in my model. Then we define different types of connections. We have contact joints in ANSYS 17.0, then mesh connections, springs, bearing, beam connections. So we define different types of connections as per my requirement of the object. You can see in the connection model. Then we apply the meshing. So today we are going to see how to do 1D meshing, or we use beam element. So we define the beam elements for my line bit of the roll cage. Then we define analysis settings where we apply nodal forces, nodal constraints with some displacement constraint, rotational constraint, direction of the forces, magnitude of the force, location of the force. These things we define in analysis settings. Then we define some of the different loading conditions. We generate some output for the solver, like we define the deformations, stresses. You can also find the factor of safety using ANSYS 17.0 directly. It can calculate the factor of safety. So these are the things which we will see. Then we review the results using the solution information where we define the different solver outputs, and then we see the results of deformation, stress, factor of safety, and other parameters. So let's start with opening of ANSYS Workbench 17.0. So this is the GUI of ANSYS Workbench 17.0. So the first step is to select the type of analysis which you want to perform. So today we are going to see how to perform static structural analysis on the 1D, using 1D meshing on the roll cage of Baha. So I will select the static structural and I will drag it to the this project schematic. So it will load the complete process flow. So you can see this is the static structural where it loads engineering data, geometry, model, then setup, solutions and results. So we have to follow this process as given here. But before that, as we are doing the 1D roll cage, so there are different pipes in the roll cage, and we have to first check whether they are properly connected or not. So before doing the impact analysis or torsional or bump analysis or rollover analysis, my suggestion is to first perform a free run where we check the connectivity of my entire roll cage members. Because if my roll cage members are not connected, then the force transfer or the constraints transfer will not be proper. So I will just delete this static structural, and before static structural I will import modal and perform a free run using modal analysis where we give a frequency range of say 0 to 1000 and see different mode shapes how my model is behaving. So I will rename it to free run to check the model connectivity. Then right click on the geometry, select import geometry, say browse to see the location of where I have saved this file. So I have saved this 1D file here on as IGS file format. So I will select this file and say open. Then I will go to geometry, again right click and say edit. So it will open a design modeler where we can assign the cross section, see the different components and different properties of my model. So before clicking on generate, you can see here the different detail view is given, which specify that what we have to import is solid bodies. So we don't have any solid bodies, so we'll say no. We'll say surface bodies, we don't have any surface bodies, so we'll say no. We have a line bodies, so we'll say yes to line bodies. And then we will click on generate. So this import file is not generated yet. You can see here a lightning icon is there. So I am not able to see any model here because I haven't generated it. I have just selected it. So I will click generate. So you can see my model has been generated here with 37 parts and 37 bodies. So these are the different bodies which my component has imported. So this is fine, it looks nice with me. So now I will define the cross section. So to define the cross section, I will go to concept drop down menu. From here I will select a cross section. I will select a cross section as circular tube. I will assume that my cross section is, you can say here it is in meters, so I will change the unit. So I will click on drop down menus of units and select millimeter. Now I'll assume that my roll cage dimensions, that is the inner radius is 11.7 mm and the outer radius is 12.7 mm. That is the cross-sectional dimensions of my roll cage, and I will directly assign it to the different components. So I will select all and define the circular tube cross section which I have defined here. So I have assigned it to everybody. You can see here circular tube cross section has been defined. So you have to make sure that you have assigned a proper cross section to it, because if you haven't assigned a cross section, it won't do a meshing or it will generate an error. So once this is done, so I will minimize this and again go back to my workbench project view. And the next step is to go to the model view, where I can edit the different parameters, define the mesh, loading conditions, output results. So I will right click on model and say edit. So this will start my mechanical ANSYS 17.0. So my mechanical ANSYS 17.0, as you can see here, is open now. So this is my model, and you can see here, you can press the scroll mouse button to rotate, control plus mouse button to spam, scroll down, scroll up to zoom in, zoom out. So this is the first thing, that my geometry, you have to make sure that there is a tick mark, green tick mark here, that the cross-sectional properties has been assigned properly on the geometry. Then the next thing is coordinate system. So I will select the global coordinate system. Connections also, you can check here, there is no as such connections required, so these connections are okay with me. Then I will go to mesh, and in mesh I will select sizing. Under sizing I will select adaptive. Elements size to, I can say, 10, and I will click on generate, right click and say generate mesh. So with this my meshing will get generated. So this is my first overview of meshing, keeping the other parameters as it is. I'm going to explain what are these other parameters and how you can change these parameters and get the results. So you can see this is my 1D meshing is done. You can see this is quite a good mesh. And let's check the number of elements. So it's 5933. It's pretty good enough. So I will explain you the different parameters, like what does the coarse or fine or medium means, then what is initial size seeds. So I will explain you later on what are these parameters and how you can update it. So I am just right now I am just trying to see whether all these members are properly connected to each other or not. So I will go to analysis setup, select the maximum modes to find. I will say 10. So I want 10 modes to find, or you can say 20 modes I want to find. Then limit search to range. So I will define the frequency range from 0 to say 1000 Hertz. This will generate the frequency. I have inputted the values of frequency from 0 to 1000, and I will select solution to get the output. So I will right click, say insert deformation and total deformation. So I only asked for the total deformation. I am not bothering about the rest of the results, because my aim of this particular run is to see the model connectivity. I don't want to find these stresses and deformation because of this vibration and all. I just want to see that whether my complete geometry is connected or not. So I will right click on solution and say solve. So this will initiate the solver. So you can see here ANSYS Workbench solution status with overall progress, preparing the mathematical model. So this is solving. It will take a couple of minutes to solve this model. So we'll wait for some time so that it can solve the entire model. So now you can see here my model has been solved. So I will click on total deformation to see the results. Select from here the graph portion to see the entire control plus select all. So and say create mode shape results. So it will generate all these shapes and say evaluate all results. Now if I click on total deformation, you can see it is also showing my elements. So I will go to no wireframe. So now you can see this particular beam has moved out. So it is not connected. You can see. Now if I go to deformation 3, this particular beam has moved out. So the geometry is not connected. You can see here. This is coming out of the geometry. So that is the aim of my analysis, that whether my complete geometry is connected or not. So you can see here this member is only vibrating. So this is not properly connected. So now what I will do is I will again go to the design modeler and establish a connection between it. So to establish a connection, I will go to create, tools, connect, say control all to select all the edges. Enter the tolerance value as 0.01, so it will find all the gaps which are greater than or equal to 0.01. Say apply, so we have selected 72 edges out of these 37 parts and bodies. Then location, I will select interpolated, so it will interpolate the location of joints. T-junction, there are so many T-junctions you can see here, there are continuously joining of members, so I will say preserve split edges, so whatever the edges it will split. So you can see here, this is the common edges, so whatever the edges it will split, it will preserve those edges, and then I will say generate. So now I have, you can see here, all the bodies and parts have been connected. But there are some which are not getting connected, so there is only 2 which is not getting connected, so I will manually connect them. So I will again go to tools, connect. So I will select this one and this one. Reduce the tolerance value. I will select T-junction, preserve, and say generate. So 0.001, say generate, so it is not getting generated. So I will say delete the first connection which I have generated earlier. Again go to tools, generate, select all the parts, 0.1, say apply, select location as interpolated, T-junctions, preserve edge, right click in connections and say generate. So this is same, this is happening that these 2 are not getting connected. So I will change some of the other parameters. So there's tools, connect. Select all, 0.01, say interpolated, resolve split edges and say generate. So now you can see I have one part and one body. So there is sometimes because of the tolerance these parts doesn't get connected, you can see here. So I have changed the tolerance value from 0.01 mm to 0.01 meters. So now all my parts have been connected. I can see here one part body is there. So now I will again go back to this. I will close this design modeler and say update. So it will start the mechanical. So file, and I will say refresh all data. So whatever I have edited the geometry in design modeler, it will directly bring it here. So you can see the geometry is now singular. I have a single geometry where the cross section and everything is already defined. So you can check in the properties that volume, mass, length, cross sectional properties are there. Cross sectional areas IXX, IYY. Then I will go to the mesh coordinate system is okay. So I will again go to mesh, say adaptive element size to 10 and say generate mesh. So again we will see the meshing is quite good, no issues with the meshing. Now analysis setting, maximum modes to find all these parameters as it is, and then I will say solve. So right now also I am doing free run to check my complete model is connected or not. So this is again solving for free run to check the model connectivity. So now you can see the total deformation plot on different sections. So my entire model is vibrating now. So my entire roll cage is connected. So I can proceed for the static analysis on using different loading conditions. So that is the most important part before starting any analysis, that to check whether my entire geometry is properly connected or not. So with this, if I see any geometry or any deformation shape, you can see the entire geometry is properly connected. So this looks fine. So I will close this model. Also I will close this design modeler. So now I will move to the front impact analysis. So I will select static structural, drag it here. I will rename it to front impact analysis. So the best part of ANSYS is you don't have to do the meshing and geometry editing again and again. You can just simply drag this and connect it here. So whatever the meshing, geometry editing I have done earlier for free run analysis is been directly linked for front impact analysis. So I will just right click and say update. So all these parameters will be updated for the static structural front impact analysis. So every time we have to just update the loading conditions, solution output, and view the results. Rest, meshing and everything can be used again and again. So you can see here it is been updated. So I will double click on model to open the mechanical ANSYS 17.0 so that I can apply the loading conditions, check for the results. So you can see here the meshing is already done. I have used the same mesh which I have already done for the in free run. So I will directly go to the static structural to apply the front impact loading condition. So now I need to apply a force in the front member. So I will go to static structural. So I will first select here from nodes, or you can press Ctrl N to highlight the nodes and select these nodes. So I have selected these nodes, press Ctrl. So even if you are able to see these nodes are in up and down motion, still don't worry about it. This is perfectly okay. So it has selected these nodes. Just say right click, select created name sections, say front member force. So I have created element sets, node sets, so that I can apply a force on those node sets. So I will go to direct FE drop down menu, which you can see at the screen at this location. I will select nodal force. From here, named section, I will select front member force. Then I want to apply a force, say in x-axis of, let's assume I am applying a force of 10,000 newtons. So whatever the g-force you calculate based on your deacceleration or whatever calculation you follow. So in that much amount of force you can directly apply here. And at the below of these options you can see divide loads by nodes. Say yes. So what is the total number of nodes you have selected here? This total force will get divided by this and is applied automatically per node. So you have a uniformly distributed loads automatically applied on the front member. You can select all these members, but on this roll cage you can see if the impact will happen, in the first point of contact will be this. So I have selected these nodes only. Then I will apply constraints at suspension mounting points. So again I will select nodes and select these two, then these two. So I am applying a constraint at front suspension mounting points, at lower suspension mounting points, front. So I will right click it and say create named selection, say front suspension, press enter. Similarly, I will select the rear one also. So these two nodes, then these two nodes. So these are the for lower. Similarly, I will select it for upper suspension mounting points. Then these two and these two. So I have selected 8 suspension mounting points for rear. I will say create name rear suspension mounting point. So I will go to static structural, direct FE, nodal displacement. So I will select front suspension. I don't want the displacement in y-axis because if the impact will happen, my roll cage, I am saying that it should not go in upward or downward direction. So I will fix this Z translation, I will fix, rest I will keep x and y as free. Then again I will go to static structural, direct FE, rotation, and I will select for front suspension, all the rotations is fixed. So I have fixed the Z translation and all rotation for the front suspension mounting points. Then for rear I will go to nodal displacement again, select rear suspension mounting points and constrain complete translational degrees of freedom. Similarly for rotation also I will select rear suspension mounting points and fixed all the rotational degrees of freedom too. So I have constrained here the rear suspension for all 6 degrees of freedom, and front I have constrained only the Z translation and XYZ rotation, and I have applied the force. Now I will go to the solution and right click on solution, select insert deformation and select total deformation as the output. Insert beam tools, select beam tools for the maximum combined stress, minimum combined stress and direct stresses. So I want to see these results of element stresses. So I will select these as the outputs. Then again right click on solutions and say solve. So I have initiated the solver again for front impact analysis. So if I click on total deformation, you can see this is the total deformation. So if I go to graph, say plot, and you can change it to wireframe mode to see the initial and final condition, that how much the deformation is going and how the members are deforming. So this is a quite good results. So in the similar way you can perform on your Baha roll cage or Baha ATV these front impact analysis. So with this I have completed the front impact analysis. You can capture the results from here itself also. So I will close this window and move to the next one. That is, again I will import static structural and say drag it here and say model and transform it here. Then say right click and update. So I am following the same procedure for say side impact analysis. So this has been updated. You can double click on it to open the mechanical ANSYS 17.0. So again I have the same roll cage with meshing is done already. Then I will again go to nodes and select the nodes of the side member. So the side member or side impact analysis is for two cases, front side, this one side and the other one also. So my suggestion is you should perform both the side impact analysis. I am going to show you right now only the one, but you should definitely perform both of them. Even though your model is symmetric, still my suggestion is to perform both. So I will create a name section, say side member, where I will apply force and the suspension mounting points. For side impact I will constrain only the lower suspension mounting points. I will select these two, then these two as well as these two, and here also I will select these two, these two, these two and these two. Say right click, create name selection, CSPN suspension mounting for constraint. So I have two names, one is for 4, one is for constraint. So I will go to direct FE solver, nodal forces, select the side member force, this one y axis you can see here, this is global as compared to global, this is in negative z y direction, so I will say minus 15,000, and it will divide per node. So make sure you keep yes here. Then direct FE solver, nodal displacement, suspension mounting points, constraints all the suspension, all the degrees of freedom, and for rotation also I will constrain all the degrees of freedom. Then in solution I will go to insert deformation, total deformation, and beam tools for the stresses, and say solve. So this gives us a very high-end results with very less amount of time. You have to just make sure that the calculation of forces and location of constraint should be proper. So how far or where is your suspension mounting location? You have to be very careful about that, and also the force calculation. You have to be careful about that too. So this is the deformed shape. I will show you through wireframe also, you can see. So this is how the deformation is coming, and you can see the stresses also. So this is the directional stresses which are coming. So this is direct stress which is coming on my model because of this side impact. Now let's move to the next. I will rename this as side impact analysis. Then again bring static analysis. You can bring it here. Connect this model to this one. Say update. Every time you bring the model, just click on update, so it will update the model. So with a single meshed file, you can perform all the different types of analysis, just changing the loading locations and constraint locations. So this has been updated, so I will double click on the model to open the model mechanical ANSYS 17.0. So again I have my model here, you can see I will fit to the screen. So I have a model, I will check, this is mesh model. Now I want to perform the rear impacts. I will rename it here as rear impact analysis. So similar way I will go to nodes, press Ctrl and select all the rear member nodes. Just make sure that you have selected all of them. So I missed this one. So okay, now I have selected all. So right click, create name selection, rear member, force. Then for rear member, I will select only the lower suspension mounting points, these two locations, these two locations. Similarly, these two locations and these two locations. Say right click, name section, rear suspension, and these two plus these two plus these two. So even if the nodes are you are not able to see them proper location, that doesn't mean they haven't selected. This is just a graphic representation. Then front suspension. So now let's follow the same process. Nodal force, rear member force. This time I will apply x-axis 15,000 Newton divided by load per node, yes. Then nodal displacement Rear suspension, I will make sure this is fixed, rest is free. Similarly, nodal rotation for suspension is fixed. Similarly, nodal displacement for front suspension, everything is fixed. Then nodal rotation for front suspension is fixed, everything. I will go to solution, insert deformation total, solution, insert beam tool, solution, right click and say solve. So with this, you can see the results of rear suspension analysis. So this is the deformation of rear suspension, rear impact analysis. I will turn off the maximum and minimum value so you can see the animation. So this is what the maximum deformation is coming because of the rear impact, and this is the animation plot. Then we'll move forward for again static structural imported here. So front side, rear I have done. Now let's do a torsional analysis. Torsional. We'll link the same model here and say update. So this is being updated, as you can see here. It is saying that solution and results are not added and there is no setup. So I will double click on model to open my mechanical NC 17.0. So as I am doing the torsional, so I will, in torsional there are two cases, anti-clockwise, clockwise in front, anti-clockwise, clockwise in rear. So I am showing you only one case, that is clockwise front. So I will have these two suspension mounting points, these two and these two as right front, and similarly these two plus these two plus these two plus these two, left front. Then here I will select the complete 8 suspension mounting points. And say rear suspension mounting points. Again go to static structural, say direct FE nodal forces. Select right front. So in Z axis, let's say I am applying 10,000 Newton of force. Then again go to static structural, direct FE nodal force. Then on left I am applying a force of minus 10,000. So one up, one down, that means it's a torsional. Then direct FE nodal displacement fixed at the rear end, completely fixed. Rear suspension. Then direct FE nodal rotations, rear suspension is fixed. Then in solution, right click, insert say deformation total, insert beam tools, then right click on solution and say solve. So with this, torsional analysis has been completed, and you can see the results of torsional analysis. There are sometimes people see that if you are getting results faster, they are not correct. This is not a case. I just want to mention that point here. So this is the total deformation. You can see the animation of it. You can see in wireframe geometry also. So this is the one case. My suggestion is you should perform all the 4 cases on this. Then let's move to the next one, that is bump analysis. So I will again select this geometry and drag it here and say update, or you can select this same torsional one here and just delete this one, this connection. I have attached the torsional one because I am applying a bump force at the front suspension mounting points and constraining the rear, so I don't have to create again the FE modeler selections. So I can use that same one. So I have just updated this model, as you have seen, and this has been updated. So it is still loading, so it will take a couple of minutes to update every parameters. Yeah, it has updated now. So I can use the same name selection, as you can see here. So I don't have to create the name selections again. I can use the same name selections, that is right front, right left, right rear, rear suspension. So I'll go to direct FE nodal force in right front. Let's assume I want to apply a total bump force of 10,000 Newton. So I will apply 5,000 on right and 5,000 on left. If you want to apply it once, you can apply once also. So I have just saved some time by using the same model which I have done for the torsional. So I had nodal displacement, then rear suspension mounting points. I have fixed everything here. Similarly, nodal rotation, rear suspensions fixed. Then insert deformation total, insert beam tool, and solve this. So with this, I can get the results of bump analysis. In bump also, my suggestion is to do front and rear both bump analysis. So this is the total deformation. I can show you with the help of a graph, and this is the animation you can see. So this is the maximum deformation of 10,000 Newton. So why I am getting this much of deformation? Because this roll cage is not correct. This is not as per the rules, because I intentionally did it because many a times I have seen people use the same type of roll cage which I have shown in these types of training sessions. So that's why I have designed a roll cage which is not as per the rules. So please don't copy this roll cage. And there, as you can see, there is no cross member. That's why there is a huge deformation. So this is, I am just explaining how you can solve these different cases using NC 17.0 academic license. So I am using the same academic license. So you can follow the same process and solve it using NC 17.0 academic license. So I will close this. So I am done with the front side rear torsional bump. Now I will proceed to rollover. So I will select static structural, again drop it here, and I will select rollover analysis. Select this model and assign it here, and say update, right click, update. If you think I am going too fast and if you haven't catch anything, feel free to let me know so that I can repeat that step. So double click on model to open the model in mechanical. So my model is here. Now I want to do a rollover analysis where my case is when my roll cage is rolled, front rollover happened, and the impact is on this top member, this angular member, the first impact will come, or you can say here also the first impact will come, and that impact will be angular. So to apply an angular impact, I will right click on the coordinate system. I will define a new coordinate system. I will select the nodes. I will apply it here. Apply. So I have a independent local coordinate system here, and I will rotate this coordinate system to 45 degrees. So now I will apply a minus z-axis force so that I get an angular forces. So in transformation, you just select R, Y, that is rotate y-axis, and rotate y-axis to 45 degree. So it will rotate the y-axis in 45 degrees. Then the process will be same again. So now I will select these nodes, because the force or the impact, first impact will happen here itself. So I will select these nodes as well as these nodes too. So I have selected these nodes. Again, right click, create name section. So I will name it as rollover force, so that I can know that on this name selection I have to apply the force. And the suspension mounting points, so I will select all the suspension mounting points, these one, these one, these one, these one, to apply the constraints. These one. Oh, I have selected. So again, if you have selected more, so you can again click there to deselect them. Press Ctrl and keep selecting the nodes. So click again. So make sure you have pressed Ctrl button, otherwise you cannot have a multiple selection. Create coordinate system. Create. I don't have to create a coordinate system, so I will delete it. Okay, I will again select it because I have selected a wrong option. Here I am choosing arbitrary any two nodes for suspension location, but you can have a proper calculation and apply the constraints at proper location, so you will get a good results. Don't select it arbitrary. So you might know the distance from this end to the suspension mounting, so you can apply the forces there. So suspension mounting, then go to static structural, direct FE, nodal force, say rollover force. I will change the nodal coordinate system. So here I can't change the nodal coordinate system, so I will assign the nodal coordinate system first. So I will delete this. So go to direct FE, nodal orientation. So select rollover force these nodes with not a global system but a coordinate system which I have created. So this is the coordinate system which I have created, so I have assigned it here. Again I will go to direct nodal forces, select rollover force, and in z-axis I will say of minus 10,000 Newton the force is coming on these members divided by the nodes. Then direct nodal displacement, suspension mountings, constraint everything. Then direct rotations, suspension mounting, insert deformation total, insert beam tool, say solve. So the analysis has been done. So let's see the deformation. So this is the deformation. So this is how the deformation pattern will look like if rollover happens. So as you might know that last year there is a huge rollover happened with so many teams. So I think this is very good analysis you should perform to see how your members are deforming after the rollover happens. So now we'll move to the next type of analysis. So I have done with front side rear, you can say torsional bump rollover. Now the next is and the last is normal model analysis, where we see how my model is behaving in the normal model analysis. So I will pick the same model here for normal model analysis, say update. Double click on the model to open the mechanical ANSYS 17.0. So the mesh model is here. I just need to constrain this model. The rest everything is same, so I will go to the nodes. Select two nodes here, 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 two nodes here. Then on this two nodes, two nodes. So I am constraining all the suspension mounting points. So right click, name selection, suspension mountings. Analysis setting, number of modes say 20, limits yes, 0 to, now the maximum range is depends on your calculation, like whether you want to combine the engine vibration, road vibration, everything in one, or you want to perform it separately. So let's assume if I combine everything once, I am putting 300 Hz as the maximum limit. Then I will request for total deformation and force reaction. So I will say solve to initiate the solver. So you can see this is the total deformation which is coming. So you can select control, drag it here. You can say graph, select control, drag it here to select all. Right click and say create mode shape results. It will create all individual, but you can see a lightning symbol here, so I will say evaluate result, all the results. So now you can see the deformation patterns. I haven't constrained this model, so let's constrain the model. Nodal displacement, suspension mountings, constraint, then nodal rotation, suspension mounting fixed. Again we will solve this. So I'll go to graph, select it from this end to this end, create mode shapes and say run. So this is my first mode. So I perform modal analysis because you can see the deformation because of the vibration which is coming here. So on 38 Hz this portion will have this deformation, and on that deformation, if rollover happens, then the rollover force adds to it and gives a larger deformation. So I have to do something to prevent this. So I can put a cross member here at the top or something which increase the pipe thickness. So that's why I perform a normal modal analysis to see whether the deformation because of these frequencies and the forces acting on the roll cage should not be in the same direction. So you can see the different deformed shapes. So mainly the deformation is on the or you can say from this to 20th. So on the side member you can see also the deformation is coming because of the vibration, but the vibration frequency is 192 Hz, which is quite huge. I don't personally think that this much of vibration will come on the roll cage, but it's your call, so you can decide, it's your own. But you can see in 101 the mode shape is on the side members, so you have to be very careful to have a proper triangulations to give the reaction to these vibrating forces or the vibrating deformations. So with this we have completed front, side, rear, torsional, bump, rollover and modal analysis. So if you still find any issues / queries, feel free to contact us anytime via support@aviation.com. Thank you very much.